Good evening, everyone. You are all muted by default when you enter the meeting. We will be starting now with Dr. Nawal GEMAYEL. She will be our speaker in our session. If you have any questions, go ahead and ask them in the chat. At the end of the presentation, we'll have a section for discussions and questions.
Hello. Hello, everyone, and welcome to this first session of Introduction to Artificial Intelligence. This introduction is intended to people who have a minimum background of programming, but not necessarily having a artificial intelligence know-how. Are you seeing the screen?
Yes, go ahead.
Okay. So to begin with, I'm going to have in this session, we're going to see a glimpse of some history of artificial intelligence, talk about basic applications, types of machine learning, and machine learning algorithms. Within this, we are going to see the difference between artificial intelligence and machine learning. And before I begin, I want to tell everybody that this session is intended to introduce you to artificial intelligence, to machine learning, and during the sessions, the 6 sessions that we are preparing, the idea is that you get the hands on one way to use and start working with artificial intelligence and machine learning. It is a large domain, so we are not intending to give you everything, but at least one way so that you begin working and programming and getting results with artificial intelligence. So I have to begin with a timeline where I will discuss a little bit of history in artificial intelligence. So it's around 1955, the first time that the artificial intelligence word appeared, and it was within a conference, and they started saying that artificial intelligence is whenever any machine would do something that would be a human, kind of human or automatic. And there was this Alan Turing test for machines to say that whenever a machine would become intelligent enough so that it would trick humans to think it is a human, then we would call that an intelligent machine. And it was only until 2014 that we really had a machine that would trick a human into thinking it is a machine. So artificial intelligence developed and programs were written, and it was promising until a time where computers were too slow to cope with the programs that the engineers were making. So around 60s and 70s and the 80s, there was a winter in artificial intelligence where we thought that artificial intelligence was a false idea and we would never get there. But with the development of new computers, artificial intelligence had a new spirit. And in 1997, we had Deep Blue, a chess-playing computer that defeated the champion Garry Kasparov. And then we had a new booming in artificial intelligence. But the real big booming was in 2010, where GPUs appeared, and we have the deep learning algorithms that we will talk about later on. And this is when really we have applications that resembled artificial intelligence machines, and we have everything that we know today and is still developing towards the future. So the 4th industrial revolution started at around 2010 with the GPU appearing. So when we talk about artificial intelligence applications, we talk about optical character recognition, self-driving cars, intelligent robots, smart investment advisors for businesses. These are kinds of software. We have in healthcare a lot of artificial intelligence for image processing that help doctors evaluate the images and know better when there is a disease or not. We have speech recognition, speech synthesis, virtual reality, smart homes, and many, many more applications that are not listed in here. These are just a sample of applications. But when we talk about intelligent machines and intelligent robots, an issue appears. It is the civil responsibility issue. So once machines become autonomous, they become intelligent, they are going to move alone like the self-driving vehicle. There arises a question of responsibility. And it happened that in 2018, an Uber autonomous car hit and killed a cyclist. So then the first thing happened, they stopped testing the cars on real roads because there is a big issue in here. And there is this issue of civil responsibility. So in your point of view, could a machine be considered responsible for an accident like this? Because it was the machine who hit the human. And what if the robot is guilty? What do we do? Can we put a robot in prison? Does it do anything to put a robot in prison? Who is going to go to prison? Who's going to be held guilty? Is it the engineer behind it? Is it the company? So I do want to know your point of view about this, your opinion about it. Elisa, did you have poll results for these questions?
Yes, now we have the poll results for if we know the difference between machine learning and AI. So I will be sharing the poll results right now. Okay, so is the result available? Is it on the screen now?
Yes.
Okay, as we can see, 37% of the answers were that we know that the difference between machine learning, what it is. However, there are 56.25% who don't know the difference between them, and 6% who think that machine learning and AI are the same. So now we'll be answering this question in the presentation with you, Dr. Nawal.
Yes, yes, okay. So the questions I have just asked are going to be answered within the presentation.
Yes, you are going to.
So they are going to be answered within the comments.
The answers within the comments, we will discuss them at the end of the session. The answers in the comments are answering about who is to blame if a car crash happens and the car is automated.
Okay, okay. So I'm continuing on the difference between artificial intelligence, machine learning, and deep learning as well. So artificial intelligence is in fact the domain. So it's a whole domain. When every time you talk about any machine that could have intelligence, this is artificial intelligence. So it is in the following definition, it is the engineering of making intelligent machines. Whereas machine learning is within artificial intelligence, it is the branch and it is the highest level of artificial intelligence. It is the brain, and it is to program machines to learn without being programmed, because classical robotics that we also consider within artificial intelligence is to have a model for the machine. So describe a machine with an equation, a predetermined equation, and then give it inputs and get outputs. So I give it a force, I get a movement. But when I talk about machine learning, I talk about a programmed machine, yes, but at the same time, I talk about a machine that I will give it data, correct or incorrect data, and it is going to learn by itself to recognize this data later on. So this is machine learning. When we talk about deep learning is profound machine learning, where we have a lot of levels in the neural network. We are going to describe neural networks in this session. So we have large programs, we have a lot of loops and a lot of levels. So this is what we call deep learning, and this is what we said has been developing from 2010 onwards, because we have computers that are sophisticated enough, that are fast enough to cope with these big programs. I hope this was clear for everybody. So I want to move to machine learning now, because the basic thing, the most important thing for us to know in artificial intelligence is machine learning. So we have basic types of machine learning. We can divide them into 4 different classes. We can call them supervised learning, unsupervised, reinforcement learning, and transfer learning. Supervised learning is when I give the robot samples and I tell the robot these samples are, in this example, apples, and these samples are bananas, and afterwards the computer is able to recognize an apple when it sees it and recognizes a banana when it sees it. And of course, it would develop into more and more sophisticated examples, but I always have to give it labeled examples, and then it will be able to label them by itself later on after it gets trained. Unsupervised learning is when I have large amount of data. When we talk about big data, if we talk about big data, we have a huge amount of data, and usually the problem is we are unable to label them, like all the messages that are in Zoom, for example, and I want to go through all the videos that have been there, and I want to sort them out. I want to classify them. So unsupervised learning, instead of labeling the samples, it classifies them into different categories without even knowing how it is classifying them. It looks for similar features and finds a group of inputs with similar features, and it classifies them. So if I give it things that are really different, like these 3 images, it can classify, let's say, color or shape. So these are what we call features. Reinforcement learning is a little bit more advanced than the basic two, and it is when I give the computer sample, but I don't give it a label. On the other hand, I give it either a bonus or a punishment. So it is another way of learning, of teaching the system, but instead of giving it a fixed label, I give it a positive reward or a negative reward, and I also can train the system to learn things. Transfer learning is, in fact, not another way of learning. It is how to use the systems that other people have developed. So when I talk about transfer learning, this is the traditional machine learning that is described on the left side. I have samples. I have one learning system independent from the other. So if I want to make, let's say, a system that recognizes apples as images, I want to have 10,000 images. Whereas if I want to use transfer learning, instead of going from scratch, if I want to make a system that recognizes apples, and I find on the internet a system that recognizes tomatoes, so I just import the values, the learned system, I import the weights, I import the knowledge that it has developed, and I use it, and I develop it even more so that it learns to recognize my samples. So I look for a system that is similar to it. I acquire the knowledge, and then I teach it the new data. Like, it's like comparing somebody who is learning artificial intelligence without any basic knowledge of mathematics or programming, or somebody wants to learn artificial intelligence but already knows mathematics and programming. This is called transfer learning, when you know some basic knowledge that is common to what you are going to learn and what you have learned before. So another way to classify machine learning is by how it is going to work. So it's either going to classify data, so it's going to divide it into different groups, like the group of apples and bananas that I talked about, or something that you call regression, that you sometimes use on Excel when you create a trend line. It is to find a trend, to predict something that's going to happen in the future. Like if I have the prices of homes today, depending on the features that are location, dimension, and quality of material inside. And then I want to predict what could possibly be the cost of the house that I don't know. I can use a machine learn on a regression function. So it learns a function, and then it can predict something that is not known for me. So for the rest of this seminar, we are going to have today a larger part of discussion, and we are going to discuss in the next session, that's next week, machine learning algorithms. So we are going to go into the details of the different machine learning algorithms, that is SVM, KNN. If you have heard of these, you are going to see them together, see the basics of each one of them, so that we can know them from each other and the advantages and applications of each one. Then I'm going to go through some Python basics, but for those who know programming, and I am only going to go for the differences between Python and other softwares, and what are the libraries that we usually use in machine learning. Then I'm going to go for the explanation of the method that we are going to use for the programming. So we are going to download what we call the Anaconda, and we are going to learn how to create environments within Anaconda. And then I'm going to talk about the libraries that are TensorFlow and Keras that are used in machine learning. And we are going to see an example using TensorFlow, Keras, and within an Anaconda environment, and know how to use them. And then I'm going to show you on the internet how you are going to enter into a Google Colab page and try some examples without even having to download the programs on your computer if you are a beginner.
Okay, thank you, Doctor. We still have quite some time. We
Yes.
can discuss the question that we asked at first. If an automated car was to go into an accident, what do you think? Who is to blame? We can ask our participants to unmute and answer if they would like. And we can also answer in the chats, as some previously already answered. Okay, so I'm going to go through some of the answers in the chats. There are a few who said that the team behind the car are to blame, whereas someone said that this will need an investigation. There's an interesting one saying that people who allowed testing on the road are to blame. This is something to discuss too. Most of the answers are saying that the company behind the car is responsible. The company or the team behind the project are responsible for this accident. So, Doctor, can you give us your opinion on this?
Well, in fact, it is still discussed. Usually, when we have an engineering product, it is either the company or the engineers that are behind the design that, or the head engineer of the department is the one who is blamed. In the case of intelligent machines, it is still an issue that is under discussion, because in artificial intelligence, there is a prospect that machines begin thinking out of themselves. So it is not an ordinary program where you enter the functions and the machine just does what the engineer ordered it to do. It could behave from itself. Nowadays, it is still in a very young level of self-development. I'm talking about the intelligent machine, but it could become, and it's not in the very far future, the machines could begin taking some decisions that have not been programmed. And this is where the issue of putting the engineer into blame is not really considered. It should not be considered because engineers are us. So we are to blame to a certain point, but we cannot take the blame to till the end. And it is really a very big issue that is still being debated. And I understand all the topics that, or the answers that were sent are very intelligent. What about the other question? If the robot became intelligent enough to take decisions by itself and it hit and killed a person, it could be on purpose, I don't know. Could we possibly think of putting a robot into prison? Could this be considered reasonable? Or what else should we do?
Can I give a counter argument?
Yes.
I do believe that good and evil are somewhat created by humans. So technically, an artificial intelligence is it's a deep learning or machine learning. It's teaching itself. So إذا تعلمتها منا, I guess okay, we can say we can put it in prison, but I guess if like it's learning by itself, not seeing humans or not interacting with humans, I think that it probably won't have evil. It like would only care about doing whatever the initial programming was, like what was its initial goal.
There has been many different situations where in some programs they were trying to teach the computer to respond and to classify images, and the robot, because of the available images that discriminate people that have a different color or people that have, because of the samples we are giving them, they are like this. So the robot learned to discriminate. So whatever information we teach it, it is learning, but it is learning not from one person, it is learning from the mass. So it copies the society, it doesn't copy a person. If I want to say that the society is to be blamed, this is something that's very fluid. It doesn't put anybody in prison, doesn't correct anything, it's not corrective. I don't know if you understood what I mean.
I understood.
So this is why it will not really copy what the designer did, because what we do, in fact, we program a neural network. We program a brain. Neural network is what we call an artificial brain. If I program an artificial brain and then I bring it 10,000 or a million samples that are from all around the world, and I teach it these, it is going to learn from all of these people that put the samples on the net. So all these 1 million people maybe are to be blamed because they taught it to become like this. It's not the engineer who designed it.
We have something interesting in the chats. Abdallah is saying, I believe it's the gear module in which the machine was engineered or programmed. The gear module that's responsible about judge or decide. You can jail a machine since the machine will not be considered a living being. This is very interesting.
You cannot jail a machine because not a human being.
Yes, you cannot jail a machine.
Well, I have a counter argument. What would jailing a machine accomplish? If our goal was to teach it a lesson, I don't think machines would feel bad when they're jailed for a specific amount of time. If we wanted to jail them to keep them away from society, I think it's better to shut them off, or I don't know. But I don't think jailing accomplishes anything in terms of doing something to machines.
Yes, that is very true. Maybe we can instead of shutting it off, maybe we can punish it. In the case of machines who are learning by punishment and reward, maybe a punishment would be something valid.
Exactly, but is jailing considered as punishment for the machine? I mean, if you jail a machine, would it consider it as punishment? I don't think they have the concept of, okay, I'm alone in a cell, this is punishment. But what if it doesn't bother it? I mean, we are humans, we are social creatures, we need to interact, we need our freedom, but do machines feel the same way? Do looking up machines bother them or help them learn more?
So how would you consider punishing a machine? So that I can give it some reinforcement learning by punishment. How would you punish it in this case?
Well, I'm not sure exactly, but I don't think jailing would be a punishment, or even hitting a machine would be a punishment. I don't think they would feel, well, unless programmed to feel. So
but
I'm
at
not
least
sure
up till
exactly.
now, the robots that have been designed do not have feelings. So you are very correct. Up till today, I cannot consider punishing in a way of hitting or jailing a robot would be of any use. But how would you reward a machine, or how would you punish a machine so that it learns better or stops doing something that intentionally, if we could say, it did it badly?
Abdallah in the chats is saying maybe sending a negative sign by the manufacturer or governors or etc. This is what I meant by saying punishment versus reward to the machines who are learning that way. But I don't know how exactly this would be implemented. This is something very technical. What do you think?
Yes, of course. Yes, of course, and this depends on each application. So it depends on the application. The reward and punishment would be related to the type of machine that you are creating and on the application that it has to do. So it could be within the data that you are giving it.
There's someone in the chats giving a useful resource saying an interesting book, Origin by Dan Brown. Maybe someone would like to check that out.
So what's the topic of the book?
Okay, they are saying it's a novel, but if you would unmute yourself and go ahead and share your ideas with us, that would be very nice. It has a plot twist concerning the AI, they are saying. Okay, so everyone, if you would like to unmute yourselves or go ahead and share your videos so that we can take a group photo at the end of this session.
I would really want to know if the participants were interested in the session, if they liked it, if they are interested to continue with us, and if anything they did not like, if they want us to change, maybe they can send it also in the comments. Elisa, before the time ends, because we still have around 3 minutes, could you tell us if anybody is interested, how are they going to contact you for registration for the rest of the sessions?
Yes, sure. You can all contact us on the email that was, the address that was sent from. We sent you an email that had a link to this Zoom meeting and also the link to the poll. You can send us an email to that, and you can go ahead and ask us now or our Instagram page, IEEE ULFS-II. We are all here for your to help you.
Okay, thank you, Elisa.
Doctor, we would like you to stop sharing your screen so that we can all take a photo together. Yes.
Looks like that my camera is gone, Malik.
That's fine.
You have stopped my video.
No, I'm asking you to share your video.
No, it's okay.
Okay. Okay, everyone, I would like to thank you so much for attending this introductory session. If you are willing to continue with us for the series, it will be quite lengthy. It will not be a couple only. We have many topics to discuss, as Dr. Marina Nawal shared with you guys, so go ahead